start with the warm-up and keep in mind that absolute value is referring to a number's distance from 0. So like the number negative 12 is 12 units away from 0, so the absolute value of negative 12 is 12. Absolute value basically makes the number positive, and if it's already positive, it stays positive. So go ahead and try that. Pause the video. Here are the answers that you should have gotten for the warm-up. And also go ahead and take a minute to write down the vocabulary for this lesson. So I'll let you pause and do that. So in this beginning part of the notes, these are just the properties that we can use when we're working with absolute value. So when you take the absolute value of a number, it's always going to end up being greater than or equal to 0. The absolute value of a negative number is going to be the same as the absolute value of that positive number, which is like number 2 in the warm-up. Those values end up being equal. 3 and 4 are saying that when you have multiplication or division inside absolute value bars, that you can break it up into separate absolute value expressions, like so. So see, that's kind of hard to see, but that's the separate absolute value of A over absolute value of B is the same thing as taking the absolute value of the whole fraction. So in this beginning part of the notes, these are just the properties that we can use when we're working with absolute value. So when you take the absolute value of a number, it's always going to end up being greater than or equal to 0. The absolute value of a negative number is going to be the same as the absolute value of that positive number, which is like number 2 in the warm-up. Those values end up being equal. 3 and 4 are saying that when you have multiplication or division inside absolute value bars, that you can break it up into separate absolute value expressions, like so. So see, that's kind of hard to see, but that's the separate absolute value of A over absolute value of B is the same thing as taking the absolute value of the whole fraction. And so when you're solving absolute value equations, your game plan basically is that you will take the bars off and write 2 new equations without the bars. The first equation looks just like the original but without the bars, and the second equation is going to have equal to a negative version of whatever number was on the other side. And so that'll, I think, make more sense once we start doing the examples. But you take the bars off and you write 2 equations. One of them equal to the original number, and one of them is going to be equal to the negative number of the original number that was over here. So take a look at the examples on the next page. And the first problem is a real basic problem that it's a good way to start off figuring out how to solve these equations. So if you have the absolute value of some number equals 10, if you think about it, there are 2 different numbers that make this true. If x were 10, well then the absolute value of 10 is 10. But also if x were negative 10, this would be a true statement. And so the way that you always approach these problems, even if you have more stuff going on inside of the bars, is you take the bars off and you write 2 new equations. And the first one is going to be just the way that it was, but without the bars. And the second one, you're going to set it equal to the negative version of that number. And then you would solve, but in this problem, there's no solving to do. It's just x equals 10 or x equals negative 10. And so those are your answers. And you use that same approach even when you have a more complicated expression on the inside. You take the bars off, and you write the equation first just as it is, but without the bars, and then you write a second equation where it's equal to the negative number of whatever is on that side. So then you have 2 equations to solve, so I'm going to add 1, so I get 5, add 1, and I get negative 3. And you always want to check absolute value equations. So if you plug in 5, this is a true statement. If you plug in negative 3, this is a true statement. And also, I am not going to require you to graph these solutions, but they would just be number lines and 2 points on a number line. Okay, so on number 3, if you see a negative on the number in the original problem, that the number that's on the other side of the equal sign, that needs to be a red flag. And basically, if your absolute value expression is already isolated, which I haven't really mentioned that yet, but if you look ahead at 4, 5, and 6, see these absolute value expressions are not isolated. Like there's a +5 here, and there's a -4 here. And like, so that stuff is gonna have to be taken care of first. But if you've already got that done, or it's already been done for you, and you still have a negative number over there, that's automatically no solution. Because there's no number for x that you could plug in where when you take the absolute value of 3 plus x, it ends up being -3. Because when you take the absolute value of something, it's never negative. So that's automatically no solution. Looking at number 4, 5, and 6, with these, you have to isolate the absolute value expression first. So we have to get absolute value of x minus 2 by itself on the left side of the equal sign. So we're going to subtract 5 before we can do anything else. So then that gives us this equation. And now we're good to go ahead and take off the bars and write our two separate equations. And then solve each of those. And then check your answers, and they both work, so we box. On number 5, you cannot distribute into absolute value bars, ever. So the only thing to do with this 4, because right now it's being multiplied, since it's just right in front of the bars, you assume that's multiplication. So to undo that, we divide. So then that gives me absolute value of 2x plus 7 equals 4. Now I've got it isolated. Now I can take the bars off and write my two equations. So you'd solve each of those, subtract the 7, divide the 2, subtract the 7, divide the 2, and check both of those answers, and they both work. And we'll see in a second what it's like when something doesn't work. Right now I'm kind of glossing over that. So those would be your two solutions. On number 6, this is a common place for error. A lot of times students will want to divide by the -2 and then add the 3, but that's not what you want to do, because remember, when you're solving for something, even if it's this whole thing that you're trying to get by itself, you have to undo what's being done to it in reverse order. So first thing you want to do is add the 3. So then you have this. Then we divide by the -2. And hopefully when you saw that negative sign, you kind of, it's a red flag. However, you can't make that call about it being no solution until you get everything out of the way, and so it's just isolated with your absolute value part. And so you notice that when we divide by the -2, it's actually equal to +4 now, so this is a go. We don't have to, or we can't stop and say no solution. So we now break it off into our two equations without the bars. So you just say 5x minus 1 equals 4, 5x minus 1 equals -4, and solve each of those.